The standard version of electricity that electricians learn is that current is the flow of electron beads from atom to atom and from negative to positive poles. It is the outer valence electrons that participate in this stream of particles. What induces this flow is said to be a difference in potential known as voltage, widely simulated as water running down a hill. Think of a tank of water perched up high, connected to a pipe that ends down below in a container. It is self-evident that water will flow from the tank to the container. But this is quite misleading. The simulation works not because of electricity, but because of gravity. What do the terms positive and negative mean in physical terms? What physical entity compels the electrons to rush downwards toward the positive pole? A more fundamental shortcoming of the particle flow mechanism is that it invokes the planetary model of the atom. The negative electron is assumed to be a tiny bead that is located somewhere around the nucleus of the atom. What physical object prevents this bead from flying away? What physical entity prevents it from falling all the way to the nucleus? And what is it that induces this bead to flow from atom to the positive voltage end? It is these types of questions that remain unanswered even to this day. The rope hypothesis proposes that the electron is a membrane that encapsulates the proton star. The atom is weaved by countless electric and magnetic threads, converging upon it from every atom in the universe. When an atom slides along the electromagnetic rope towards another, it reels in the two threads that form the interconnecting electromagnetic rope through which light propagates. When the two atoms meet, they either blend or push each other away, depending on whether their electron shells are spinning in the same or in opposite directions. For example, if the shells are both spinning clockwise, the atoms screw into each other and form the H2 gas molecule. If instead they spin in opposite directions, the atoms push each other away, and the rope between them regenerates itself. Imagine now a wire made entirely of iron atoms. The iron atom has an outer orbital structure that looks more or less as seen here. Under the rope model, the S and P orbitals are physical balloons that encapsulate the nucleus. Imagine now a long chain of blended iron atoms that make up the wire. We refer to these chains as serpentines. When stimulated, the entire serpentine spins in place. A closed circuit resembles a donut turning on itself along its entire extension. Electricity is not the shooting of bullets. Electricity is more appropriately visualized as a drill bit twirling in place. In a vacuum chamber, the serpentine extends from cathode to anode. To illustrate voltage, let's briefly look at the basic lead battery. There are two terminals. Lead, designated as the negative pole, and lead dioxide, the positive pole. These terminals are immersed in a solution of sulfuric acid and water. A chemical reaction takes place that induces electron beads to flow to the positive pole. Under the rope model of electricity, the reaction induces the entire serpentine making up the wire to spin clockwise from the point of view of one terminal. The other end has no choice but to rotate counterclockwise. Voltage is clockwise and counterclockwise spin of a serpentine, a series of atoms which are merged and aligned.